Okay, this is the sine function, and we're integrating from 0 to infinity. It's an improper integral, so let's write this down. So it's going to be the limit as a goes towards infinity, and it's going to be the integration from 0 to a sine a. I'm sorry, sine x. What am I saying? Get my eraser out. Doesn't look right. Sine of x dx. Relatively simple problem. Let's write this down. Limit as a goes to infinity. The antiderivative of sine is minus cosine. And my limits of integration for this is going to be 0 to a. I'm sorry, I wrote that backwards. 0 to a. Let's keep writing it down. This is going to be the limit as a goes to infinity. And what do you get there? You get minus cosine of a. Let's see, cosine of 0 is going to be 1, so minus a minus 1 is going to be plus 1. Make sure I said that right. Cosine of 0 is 1. Yeah, minus a minus is plus 1. Good. So can I do that limit? No, the cosine's bouncing around, back and forth, back and forth. So this is the DNE. Right, doesn't exist. Right, another way to look at this thing is just to look at the sine function. And I want to point out, it's sine function, kind of looks like this over here. And I got an area here, and I got the opposite of the area over there. Let's just compute the area, though, of one of these guys over here. And what's it going to be? 0 to pi sine x dx. And what would they give you? Minus cosine. Integration to go from 0 to pi. So it's going to be cosine of pi is minus 1. So minus 1 is plus 1. And then we get minus plus 1. So it's 2. So I really, the sum of this thing is really kind of easy to write down. And so this thing from 0 to infinity, if I would just look at it as a summation problem, it would just be, 2. That's the first one. The next guy would be minus 2, and then plus 2, and then minus 2, yada, yada, yada. Let me write this down in summation notation. I'm going to say it's the sum. Let's see. Get my eraser out. I equal 0 to infinity. And this is going to be 2. And then it alternates. So I'm going to say minus 1 to the nth power. Let me see if that works, though. If I took 0, I get 2. Yeah, it's fine. What do I know about this over here? Well, the an is minus 1 to the n times 2. And just, the test for divergence, looking at it, limit as n goes to infinity, minus 1 to the n times 2. It's not equal to 0, right? This is a DNE. It's a divergent sum. So this diverges. All right. Did we know that going up here? Of course we knew that going up there. Thank you.